Okay, let's start with a question. When you look at a box, what is the box? Is it the cardboard it's made of? Or is it the empty space inside? It sounds simple, but this is exactly where the confusion between volume and surface area starts. So today, let's clear this up once and for all.
Think about a water bottle, right? Are you talking about the plastic of the bottle, or are you talking about the water it can hold? They're two completely different measurements, and that's the absolute heart of the puzzle we're going to solve.
And hey, if you've ever felt a little bit mixed up by this, you are definitely not alone. It's a super common point of confusion. But I promise, by the end of this, you're going to have a dead simple way to remember the difference forever.
All right, so let's get right into it and define the difference. We're going to use a really easy framework here. It all comes down to one simple idea: the covering versus the stuff inside. So first up, we have surface area. The easiest way to think about this is just the covering, or maybe the wrapper. It's the total area of everything on the outside of an object. If you can physically touch it or paint it, you're almost certainly talking about its surface area.
And on the flip side, we've got volume. And this one's just as easy. It's the stuff inside. It's all about how much space something takes up, or, how much stuff, like water or air or cereal, you can actually cram inside of it.
And here you can see them side by side. It really is that straightforward. Surface area is the covering on the outside, like how much paint you need for a wall. Volume is the stuff on the inside, like how much air is in that room. It's always the wrapper versus the filling.
Okay, so that's the theory. But let's be real. The best way to get this to stick is to actually use it. So we're going to play a quick sorting game to put our new covering versus stuff idea to the test. See if you can guess where these go. All right, here's our board. On the left, we're going to put everything that's an example of surface area, our covering. And on the right, we'll put all the examples of volume, the stuff. Ready to go?
First up, a granola bar and its wrapper. Which one is which? Well, the granola bar itself is the stuff you eat, right? So that's volume, which means the shiny wrapper that covers it, that's the surface area. See? Simple. Okay, how about this one? Wrapping paper on a gift. This is a classic. The paper is pretty obviously the covering, that's our surface area, and the gift inside, taking up all that space, yep, that's the volume.
What about your breakfast? A box of cereal? The cardboard box is just the container. It's the covering. So that's going to be our surface area. And all that delicious cereal you pour into your bowl, that's the stuff. That's the volume.
The exact same logic works for a soda can. That thin layer of aluminum that makes the can, that's the surface area. How much soda the can actually holds, that's its volume.
Let's try one from nature. An apple. The thin skin on the outside is the covering. That's surface area. And the flesh of the apple, the part you actually eat, that's the stuff inside. That's volume.
All right, I think you're getting the hang of this. So for the next round, let's try a few items on their own, without their obvious partner. You just have to ask yourself that one simple question. Is it the covering, or is it the stuff?
Okay, let's sort these last few. First, the amount of paint for a wall. Well, paint creates a covering, right? So that's surface area. Now, the amount of glass needed for an aquarium. The glass makes the container, so that's also surface area. But how much water to fill that aquarium? Oh, that's the stuff inside. That's volume. And finally, the amount of fluff inside a teddy bear? Totally the stuff. That one's easy. It's volume.
So, this is a fun little brain teaser, but who cares? Why does this actually matter in the real world? This isn't just some abstract problem from a geometry class. It's a concept we actually use all the time, probably without even thinking about it. The thing is, this difference helps us answer really practical, everyday questions. Knowing surface area tells you how much paint you need to buy, or if you have enough wrapping paper for that gift. And knowing volume tells you if that leftover cereal will fit in your kitchen container, or how much soda you're actually paying for. It's all about planning, efficiency, and, well, not running out of wrapping paper. So if you only take away one thing from all of this, let it be this. Surface area is the container. Volume is the contents. It's the wrapper versus the stuff. And I'll leave you with one last thing to chew on. What about a balloon? Are we talking about the thin layer of rubber that makes up its skin? Or the air inside that gives it its shape? It's kind of both, isn't it? Something to think about.